The next wave of cyber attacks won't be launched by humans alone, and neither will the defense. As distributed denial-of-service attacks grow in scale and frequency, machine learning and large language models are stepping into the front lines. But how effective are they? What trade-offs exist between accuracy, speed, and risk? And how close are we to autonomous defense systems? On this episode, we are going to find out. We are going behind the scenes to hear directly from a key member of the Thales and Imperva threat research team. I'm Steve Prentice, and this is the Thales Security Sessions Bite-Size Podcast. In this episode, I speak with Johnathan Azaria, machine learning platform lead at Imperva, a Thales company who offers a rare behind-the-scenes look at how AI is being used today and what's coming next. So let's start by looking at mitigating DDoS attacks. Johnathan, can you first of all walk us through how machine learning is applied to detect or mitigate web application and DDoS attacks in your organization?
One of the issues with machine learning is that it's not deterministic in the same way as like standard algorithms. So you can run into some issues where you can train a model and then eventually it will work in a different way than you expect. And it might have some issues, especially when you talk about large language models. So they hallucinate and you can run into all these different problems. So basically you kind of have a choice to decide where to put the machine learning model and what to let it to do, and these different areas where it can help you, and each one has a certain risk and reward to it. One example is, let's say, instead of having the machine learning model actually mitigate the attacks, it can maybe look at the account and decide the configuration for that site. So this is one of the things we do for DDoS protection. We have a machine learning model that basically configures the site's DDoS protection. So it looks at the incoming traffic and it decides like what looks like an anomaly, what amount of traffic is a problem, and then we can start mitigating and just sort of sets all the different configurations and rules. And the good thing about it is that this is something that happens on a certain basis, like a weekly basis or daily basis, and you can have someone actually take a look and validate, see that everything is okay, so that even if the model isn't the best model there is, you can still use it, because if there's a problem, someone can just take a look and catch this type of issue. So the good thing about it is that it gives you a lot of value and also it's a low risk. But on the other hand, it's not as valuable as something that actually does the mitigation. Okay, so this is kind of the trade-off that you can play with. There's some other examples of models that actually look at the traffic and decide if something is malicious or not. One of the problems there is that other than the fact that they can make mistakes, and because they need to be online, you can only catch those mistakes after the fact. Another issue is that they need to be really high performance, right? I mean, they need to be able to mitigate a large number of attacks in a very small amount of time. And if they cause any sort of latency, which is very, very common with large models, so that's a bit of a problem. So this is kind of a trade-off right now. As I said, one example that we have is the model that just does the configuration, and it's been very, very useful, and it saved a lot of man hours. That is just one example that we have.
Okay, so is there any distinction between machine learning and artificial intelligence in terms of the kind of security you build?
I think it's like a very highly debated subject, like what is AI, whether AI is specifically a machine learning model or maybe a very, very highly sophisticated machine learning model. Some people say that. Others say that basically anything that imitates some sort of human behavior is AI. So you can say that the most basic heuristic algorithm is AI. So it really depends on the definition you decide to go with. But as far as my profession is concerned, it's all the same. Like we use whatever is needed in order to solve the problem. So if we are trying to solve a small problem, we might just use simple heuristics, which has happened many, many times in the past. That's really good if you have a problem that's not that sophisticated, doesn't require such advanced capabilities. And it's also very easy to debug. And also, as far as performance is concerned, it's very, very fast. And sometimes we use LLMs. heavy LLMs with all their capabilities and the amount of GPU and power that they require. It really just depends on the problem, and we just use whatever is required.
A while back, there was a cybersecurity news story about the biggest DDoS attack so far, which tracked at 7.3 terabits per second. Now, it's highly likely the next one will be larger, of course, but it shows just how focused the bad actors are on continuing to both innovate and increase the frequency of their activities. How do you keep up with all of this? I mean, the ongoing creativity of bad actors. What do you and your team members take into consideration?
Yeah, so one of the things that we kind of noticed is that even though like some attacks are larger, generally speaking, they mostly use the same technologies, more or less the same technology. We haven't experienced a large attack that was suddenly using any sort of advanced technology that we were unable to stop. Usually just the things that we had in place mitigate these type of attacks. It's usually just, as you said, being able to pool their resources. So either sometimes they can just manage to take over a lot of different devices and generate a very large attack. In other cases, it's some new vulnerability. But just because the vulnerability is new doesn't mean that the attack is new. And I have like a good example. I don't have the numbers in front of me, so these are more or less like estimations as far as I can remember. But like I think 5 years ago, there was this new vulnerability by a memcache servers that allowed one to create an amplified attack of I think like 1,200, maybe more than that. The amount of damage one could inflict was crazy, right? You could just send one packet and it would be amplified by 1,200. And if you had like a lot of bots, you could create this very massive attack. But as far as we were concerned, it wasn't a big deal. We just saw the attacks coming from memcache. It was very, very easy to block it. It wasn't anything new. So I think this is something that's relatively common in network DDoS attacks, that the attackers manage to create larger and larger attacks. But if you have your basic mitigation mechanism in place, and if you have a large enough pipe, then usually you're good to go.
What are some of the biggest challenges in getting machine learning models into production in a cybersecurity context?
So I think there are some very big challenges, generally speaking, getting ML models into production, especially in companies that don't do ML as their major thing. Because ML has a lot of special infrastructure that is required, right? Like how do you train the model? Sometimes you need special equipment, special infrastructure such as the GPUs. How do you train the models? How do you track your different experiments, the different types of models you try to run? Where do you keep these models? How do you actually deploy them? This whole thing isn't exactly done the same way as classic software engineering. And companies that didn't really have this in mind when they started are now having a bit of a problem adapting to it. I think one of the biggest things that one can think of is that machine learning is done mostly in the Python language. There are some exceptions where maybe C or C++ is being used, especially with the deep neural networks, but Python is like the go-to. And many companies just don't have Python stack, right? They just don't have a Python tech stack. And then when they start thinking about ML, they have to somehow find a way to integrate a Python into the working system. So that by itself requires some investment on their behalf. And then there's everything around that. So when you want to test a model, it's very difficult to test a model in a stage environment because it requires a lot of data to operate. So you usually need to test it in an environment that has real data that's actually flowing in it. How you actually deliver the models. So there's a concept that's called the model registry, which is a bit different than what everyone is used to. You don't exactly deliver code, you deliver some sort of a binary. Okay. So there are all these different things along the way that just don't act like normal, regular software does. And that is like just the one side, the infrastructure side. Then the other side is basically validating the solution, validating your ML models, and making sure that they behave the way they're supposed to. So as I mentioned, testing isn't that easy because you usually want to test it on live traffic. Even when you did actually test it on a decent amount of traffic, there's still no guarantee that, somewhere along the way it will act differently. So there are all these different things, and this sometimes causes some issues with trusting the model, especially by the rest of the company, by the PMs. They need to actually trust the model and trust that it will do what it's supposed to do and not cause any sort of funny accidents. And after you did all of that, and after you managed to convince everyone and actually deliver the model and have it actually deployed in production, there's the whole monitoring part, which again is different than how monitoring is usually done. Because usually you just kind of make sure that the code works the way you expect it to work. You make sure that there are no exceptions. You make sure that everything kind of performs in a decent way and that it doesn't crash. And that's usually enough. With ML, you want to monitor the results and you want to see that there are no drifts. You want to see that the data that's coming in is distributed more or less the same way over time. You want to see that the number of predictions stays more or less the same. You want to see that the distribution of the predictions stay the same. So if usually like 95% is false and 5% is true, you want to see that that keeps on happening. And normal monitoring tools don't really give you that. So again, sometimes requires either writing proprietary code that will do the monitoring for you, or just use one of the solutions that are out there, and they're not cheap at all. So these are just like a few challenges along the way. And in cybersecurity, on top of all of that, you're dealing with people's businesses, right? So you can't just upload like a model that works more or less okay. If I wanted to create a new chat that uses an LLM, I can create a very bad LLM and create a chat and upload it. And people are going to use it and it won't be that good. Okay, now I'll get better and I'll create a better chat. And as time goes by, 1 to 3 years, I'm going to have a very good chat, but with that model. So on top of all of that, there's just a lot of responsibility that is kind of sitting on these models. They have to make sure that they actually protect the businesses, and that they actually block attacks, and they don't block things that they're not supposed to block. And that is just another challenge on top of everything else I described.
What's an example of a machine learning algorithm that has been effective in a cyber attack, and what makes it work so well?
One example is a very relatively simple model that detects the kind of classic application security attacks. I'm talking about the ones that come in a single request, things like XSS and SQL injection, remote code execution, these type of attacks, the very classic standard attacks. And we figured out that by looking at the text that's coming in, looking at like special symbols, special characters, different bigrams, whatever, it was actually relatively easy to detect these types of attacks. You didn't need to create a very sophisticated model. A relatively simple one worked quite well and actually had a relatively high accuracy. I think one example that I have, although it's relatively old, but if you remember, there was the Log4Shell, Log4j attack a few years ago. And we saw that this model managed to detect high percentage of those attacks, and it was trained on data that was existing before these attacks. So it was actually interesting. It worked relatively well. I think one of the problems is it comes back to what I talked about before. One of the challenges with these types of models is that it's just expensive to deploy. It has to work very, very fast. And also it requires this special Python stack. And, right now, all our systems, at least the ones that work in real time, work on a C++ code. So all this thing of somehow injecting a model into these systems was just very difficult. So this thing just didn't really go any further than that. But this is just like one example of a model that has been very effective. Another example that is happening right now is using basically a proprietary LLMs, or maybe it's LMs, maybe it's not large language models, just language models, to detect different attacks that are aimed against LLMs.
What does that mean exactly?
So I'm going to explain. One of the problems with LLMs, you can think about it as like some sort of a human, right? It's like someone who can actually read what's happening and it can reply, and it has different types of replies, and not everything is really like structured. And sometimes people can abuse that. So it can be the very simple abuse of getting a ChatGPT to describe how to build a nuke or bomb or whatever. And it can be other things, like maybe you're talking to some store's chat and you manage to get it to offer some item for a very low price. Or maybe you can somehow get it to expose its database. So there are all these different types of attacks that can be performed against LLMs against chats or LLMs in other kind of settings. One of the things that we found very effective against these types of attacks is using small language models or just language models that aren't that big and that are very fine-tuned to look at these types of attacks. And apparently that does a very good job. It's relatively easy to detect any kind of these attacks, which is like prompt injection or exposing a database, all these types of issues. And it has proven highly effective. And actually right now we're already creating a product based on these models.
Are heuristic models still relevant alongside machine learning, or is machine learning taking over entirely in threat detection?
I think heuristic models are still relatively relevant. As I mentioned before, one of the good things about heuristics is that it's just highly effective. It's just very, very simple code. It doesn't require like multiplying matrices or anything like that. It's relatively straightforward. It's usually some sort of an if-else. Very easy to debug because you can really see what's happening and it's not convoluted neural network that's very difficult to understand what actually happened. So as far as performance and explainability and debuggability are concerned, heuristic models are very good. The thing is that if you have enough data, it's usually easier to train a machine learning model than create a heuristic model, and I'll explain why. Because when you create a heuristic model, you need to do the modeling yourself. You need to look at the data. You need to say, okay, I see that if something is happening more than X or Y times, and if something is happening together with something else, then that is malicious. You need to kind of model this whole thing by yourself. And ML models just kind of do that for you. Even the very, very simple one, the like decision tree, which is basically, again, a bunch of if-else, or random forest, which is multiple decision trees. They kind of do it for you. So if you just get the right data and you input it into these models, you just get the answers without actually having to do any of the modeling yourself. So I think, especially when it comes to cases where you actually have data, it's usually easier to just create a model yourself, to train a model using machine learning, than it is to actually write heuristic.
Okay, so what role do you see AI and ML playing in the future of threat research? Could we one day perhaps see fully autonomous defensive systems?
I think one of the things we're going to see more than on the side of defense, I think we'll see it much more on the side of offense, like a fully automated offensive system, because it just kind of makes more sense. Because when you do defense, you really need to know a lot about what's happening. So sure, you'll have all these code assistants that will make it easier to write your code and make it more secure. You'll have those, and they kind of review all the commits and all of that to kind of make everything more secure. And maybe if we're talking about the context of web application firewalls, so maybe systems that will detect new threats and write rules, which is actually something that we're currently doing. We have a system that automatically writes new rules for new attacks. I still think that when you talk about fully automated, you'll see it more on the offensive side because it's just kind of easier, right? Because you see the threat from the outside, you can throw it at whatever you want. If you make a mistake, so to speak, it's not really a mistake, just another attempt. And I think you already have some of those tools out there. I think you'll see that more and more. I think we're going to see more and more companies offering this kind of automated PT testing, and it's going to get better and better. So I think we're going towards that direction. On the side of defense, I think it's just very, very similar to what's happening with code. You just have assistants doing a lot of the work, making everything easier, but it's not going to be fully automated. You still have the human behind everything that will have to kind of validate and design the systems and make sure that everything is working correctly.
Well, this has been some truly excellent behind-the-scenes description. Johnathan Azaria, machine learning platform lead at Imperva, a Thales company, thank you so much for joining me here today.
Thanks, Steve. Thanks for having me. I had a very good time. It was a very good talk. Thank you.
And remember, if you like what you hear, be sure to subscribe and tell a friend or a colleague or a client or all of them about the Thales Security Sessions podcasts. We will be back again soon with another episode and another discussion on the topics that you need to know about to successfully carry on in the business of information security. Until then, I'm Steve Prentice. Thanks for listening.